Here is another dissolving problem. This time we're dissolving 6.9 grams of sodium hydroxide in 70 grams of water. So let's go ahead and write out our variables. So our mass of our NaOH is equal to 16.9 grams. The mass of our water is equal to 70.0 grams. So our total mass is the sum of those two values. So that is 86.9 grams. Then we need to do our temperature change. Our final minus our initial temperature. So our final temperature is going to 86.6 degrees Celsius from 22.4 degrees Celsius. So our delta T value is going to be the difference between those two, which is about 64.2 degrees Celsius. And of course we know that our C value, we're going to assume that the solution has the same specific heat as liquid water, and that's 4.184 joules per gram degree Celsius. Okay, so now we're just going to substitute into Q equals MC delta T. Q equals 86.9 grams times 4.184 joules per gram degree Celsius times delta T, 64.2 degrees Celsius. If we take a look at our units, our Celsius cancels, our grams cancel, and we're going to get an answer in joules here, which is important to pay attention to because our final answer needs to be in kilojoules per mole. So when I multiply all this out, I got 23342.45, and this is in joules. So right away I'm going to take that and convert it to kilojoules. I know that 1 kilojoule is equal to 1,000 joules, so this is really just dividing by 1,000. And that gives me 23.342 kilojoules. And there are more decimal places, but in my final answer I'm only going to need 3 significant figures, so I'll hold on to a couple more here. I'll hold on to 5, just for good measure. So now we have our number of kilojoules. We just need to figure out how many moles of sodium hydroxide actually were utilized here. So to do that, we'll convert the 16.9 grams into moles. 16.9 grams of NaOH. And we will go from grams to moles. 1 mole of sodium hydroxide, if you add up sodium, oxygen, and hydrogen, has a mass of right about 40 grams. So if we do 16.9 divided by 40, that gives us 0.4225 moles. And so then I just need to simplify this down. I have my number of kilojoules and I have my number of moles, so I just need to do the number of kilojoules divided by the number of moles. So 23.342 kilojoules divided by 0.4225 moles. And then when we divide these numbers out, then we'll have the number of kilojoules per 1 mole. So if I divide those two values, I got 55.2484. And this is, of course, an exothermic process, so this should have a negative sign on it. And this is in kilojoules per mole. But we should actually simplify this so that it has correct sig figs. And our values in our problem have 3 significant figures, so we'll also simplify to 3 here. Our delta H value is equal to negative 55.2 kilojoules per mole. And there is our final answer.